In this session, we are going to find the number of mole of water of crystallization in a hydrated compound. First, let's find out this way. From this hydrated formula, at least several points we need to emphasize is first is the mole ratio between the acid and H2O equals to 1 to n. The next point is the mass of the crystal equals to the mass of H2A plus the mass of water. This is important because H2A can be detected through the titration, but water cannot. Once it dissolves, it will merge as part of the solution and cannot figure out again. So we try to consider the problem in this way. After dissolving, the crystal become the acid and water, and we need to find out the amount of acid through titration, and that's it. So let's see. We have mass of crystal, we have molar mass, and the solution. Pick out 25 of them to carry titration against potassium hydroxide. We use the illustration again, like this, and to write down the equation. So I think you can figure out, find the amount of potassium hydroxide first. And with mole ratio, we can get the amount of H2A used in titration. Again, don't forget, only this amount is involved in the titration. Next, we convert the amount of acid into gram first. And here shows, this is the amount of acid used in titration. But don't forget, we only use 10% of the acid. And we get the amount of acid in the hydrated crystal. So back to here, this is 1.26 gram, and the acid will contribute 0.9 gram. So the rest of them, number of mole of water in crystal, this is the mass of water. Don't forget over the molar mass of water. During the quiz or test or examination, you need to find it from periodic table given. No need to memorize, and 0.02 mole. So finally, we can find the mole ratio between H2A and water. Yes. Now, some of you may wonder, is it this one? Well, no, because this amount is only used in the titration. So we need to go one step more, like this. Multiply the amount of acid 10 times because only 25 cm cube is used during the titration. According to the equation, it should be 1 to n, so n equals to 2. Of course, it looks a bit complicated, but don't worry, you can go faster after you're familiar with that. We move to next question. Highlight the information first. Now this is sodium carbonate titrates against sulfuric acid. So the situation is a bit complicated because we need to take care about the mole ratio. First, write down the chemical equation like this to make sure we will not mix up the volume and number of mole. So the number of mole of sulfuric acid used is m times v, like this. And with the mole ratio, number of mole of sodium carbonate in crystal or in sample. So be careful, the step will move faster. With 1 to 1 mole ratio, this should be equals to this way, but we need to times 250 over 25, which is 10 times more. Well, next one, in these pictures, we can figure out this is 10.3 gram. And so far, all we understand is 3.6 times 10 to the power minus mole. So we need to change the number of mole into mass. And of course, we need the molar mass of the sodium carbonate, like this. Just for you to have a reference, this is not needed in the real examination, equals to 3.8 gram. Next one is the mass of water in crystal. It's the crystal mass minus the sodium carbonate mass, like this, and of course converted into number of mole. So finally, we get what we want. This is the number of mole of H2O, and this is the number of mole of sodium carbonate. And here we have the mole ratio between sodium carbonate to water is, okay, according to the formula is 1 to n, but in the real number will be, we got this one, it's 1 to 10, so the value of n equals to 10.